observable,
He's
bro.
more observable.
My Smurf is stuck. I'm not gonna hold it.
Two, what's up?
Since you taught me this, do I have to do the rest of them?
No, we didn't even do all of them.
Which
Like,
which
keep
is
asking
questions?
Yeah.
Yeah, no, I was talking to Aiden about it.
All right, so on 11.6, we are doing separation of variables, but we are finding the particular solution. So when you're doing the particular solution, the whole goal here is to figure out what the C is. So kind of the same thing that you did in the matching game, same thing that we did Thursday, except we got to find C. All right, so I'm going to work this one out algebraically, and then I'm going to show you on the graph. Your first step when you're separating variables is always to move the dx over. And that right side is always your x side. The left side is always your y side. All right, so now I'm not really loving this guy being together because I can't separate it that way. So I'm going to distribute out that square to both my variables. So it's x squared, y squared. And that way I can actually separate the y and move it to the other side by dividing. So once again, all you can do is multiply and divide. You cannot add or subtract when you're separating variables. All right, 1 over y squared, is that going to be ln?
Yeah.
Why not?
Because it's minus 1 and it's still be 1.
Yes. So if you have any sort of exponent, not an ln. The ln's are only if it's 1 over something without an exponent. So if you have any kind of exponent, whether it's negative or positive, it's not an ln. ln is only with the exponent 1. So this one, I am going to rewrite it as y to the negative 2, so I can use power rule on it. And so when you integrate, when you add 1 to this, you won't get 0. You'll get some number, which is okay. The only time it's an ln is if you try to do power rule and you get 0, and then it doesn't work. So in this one, this is a regular power rule, so we're going to add 1 to the exponent. You'll get negative 1, divide by negative 1, and it'll just make this guy negative. Equals, what's the integral of x squared?
X cubed over 3 plus C.
Yes, x cubed over 3 plus c. And so this is your general solution. All right, but I want to find the particular solution, and I think there's supposed to be an f here. All right, and it gives me the initial condition f of 1 equals 1. Now, anywhere does it tell me I have to solve for y? No. So do you have to solve for y? Nope, you don't have to solve for y. You can leave your guy not solved for. Now, one thing I would recommend, especially if you have negative exponents, I would write those as fractions, because that's a little mistake that people make. All right, so I didn't change anything. I just wrote this negative exponent as a fraction so I don't get confused. And now I'm going to plug in my initial condition. So what am I going to plug in for y?
1, probably 1.
1. And what are you going to plug in for x?
Also 1.
Also 1, because my initial condition is 1 comma 1. And we're trying to figure out what c is. So what's negative 1 divided by 1? Negative 1. And 1 cubed is 1 over 3. And so when I minus 1/3, what's negative 1 minus 1/3?
Negative 4/3.
Negative 4/3. So c is negative 4/3. And to write your answer, you're going to take that c and you have to plug it back into the c in the equation that you plugged your initial condition into. What? No. No.
I have to use that.
I
I
can't.
don't
She's
think I've
a
heard of
math
that.
teacher. You have to get somebody else to library. No, I can't. She's a math teacher. And she'll walk by and see that you're not in here.
I'm in the back corner.
That's a
I'm
terrible.
over there by Brandon.
That's a terrible idea.
That's a great idea.
No,
She's
it's
not
not.
gonna leave her classroom. She's not
Yes,
gonna
she
leave her
will.
classroom.
She will. She will walk by, poke her head in. No, I can't do that. I've asked her multiple
What's the name of this
times.
teacher?
On the next. Okay. So I'm going to gonna plug this back in here. So my final answer is negative 1 over y equals x cubed over 3 minus 4/3 box. So it didn't say to solve for y, so I didn't have to solve for y.
Wait, so what's the point of the graph?
So the graph is just to kind of see the shape of this function. Other than that,
It's terrible.
there's no
Don't need
point.
it.
Yeah.
So,
So, rule of thumb for the graph, you plot your point. You go with the flow. Do not cross. You can touch, but you can't cross. So we're going to go with the flow of the slope field.
did you not just cross?
I touched. I touched it.
I don't know.
It
Like
looks
right here.
It looks cross to me.
Yeah, that's me.
That's touching it. That's going along
Why
with
does
the
it go
slope.
right there? What?
So you can follow along the line, just don't cross it.
Yes, what you can't do is you can't go like this.
Miss Stoll, I'm gonna like.
This
mess
is
up
bad.
this.
This is bad.
Can I just like in the gap?
As long as you don't cross it, like as long as you don't, because if you go in the gap like this, I don't know, going in the gap is a safe way to go.
Yeah, it's me.
Like you're saying, like go like this.
Yeah.
Yeah, that's fine.
But it's like there's some like that are in the middle, and then
Just be close enough. They're not gonna put a magnifying glass on this.
They will not. Yeah, they're not going to be zooming in. What they're going to look for is you not going with the flow. Like this would not be going with the flow. That would be bad. You're crossing all these slopes there. Go with the flow. All right, next one. All right, find the solution. Y equals f of x. So right here, this in the directions is telling me solve for y. So this one I am actually going to have to solve for y for. But first I'm going to separate the variables and find the general solution. So I'm going to move the dx. All right, now how would I separate the variables to get y's on the one side?
multiply by y.
Multiply by y, good. So y dy equals 2x dx. Now that I have y's on this side, x's on this side, I can integrate. So what is the integral of y?
Y squared over 2.
Y squared over 2. What's the integral of 2x?
2x squared over
Or x.
2.
Which the 2's will cancel and you just get x squared.
Mhm.
2x squared over 2, those guys will cancel. And then plus c. All right, now, I'm not finding c yet because the directions told me I need to solve for y. So I'm going to solve for y next. So if I want to get y by itself, what do I do? Multiply by 2, and I'm going to multiply this whole side by 2. So I get y squared equals 2x squared, because 2 times x squared. And 2 times a constant is still going to be a constant. Okay, how do you get rid of the square? Square root, and every time you square root, you got to put a what?
Plus minus.
A plus minus. Now in your final answer, you will only have one of them, either a plus or a minus, and that's where your initial condition comes in. So when you look at your initial condition, do you want the positive or the negative square root?
Positive.
Positive, because your y value is positive. If your y value was negative, you would want the negative square root. Does that make sense? Okay, so we are going to take the positive square root and we're going to not do the negative square root. But let's plug in to figure out what c is. So what are you going to plug in for y? 1. And what are you going to plug in for x?
2.
2. How do you get rid of the square root?
Square.
Square it. What's 1 squared?
1.
1. All right, what is 2 squared?
4.
Times 2?
8.
So this whole thing here is 8, which makes c
-7.
-7. All right, now when you are plugging your c back in, it has to be plugged back into the equation right before you plugged in your initial condition. So this c is a no, this c is a no, because those c's are constantly changing when you're solving for y. Does that make sense? So these c's right here are not -7. We have altered them.
Because we multiplied by 2.
Right, because we multiplied by 2 and then we took a square root, so we've changed the c. So that's why when you plug your c back in, you plug it into your very last step of simplifying for y. Don't plug it into any of those previous ones. That's the mistake that people make. All right, so my final answer is going to be y equals, it's the positive square root, not the negative, 2x squared minus 7. So you plug your c back into the very, very last step.
Wait, you just said not to do that though. Wait.
You plug your c into the last step of the simplifying for y.
Oh.
Like, don't plug it in here, don't plug it in here, don't plug it into those c's.
Yeah.
It's the very, very final before you start solving for c.
If we want to use in the test, do we have to graph it?
Unless it says, like, the only time you're gonna see where you have to graph it is it's gonna be on a free response question, which I did put one on your test here, but a lot of times it's just part A and it's gonna say sketch the solution going through the point 2, 1. And so all you gotta do is draw it out and sketch along the slope field.
But the slope field will already be there.
The slope field will already be there, yes. And a lot of times it's 1 point on the FRQ, like it won't be more than 1 point, but it's an easy point to get as long as you don't cross lines. All right, how much time do we got?
We're leaving in a minute.
Okay, let's go. I want to do 39, and that's all I really did in the other class too, so that's fine. All right, on this one, first step, remember the slope field doesn't actually matter, that's just practicing sketching the solution. The math part here is finding the particular solution. Integrating, or separating the variables, integrating, solving for y, finding c. Now on this one, do you have to solve for y? No, because it just says find the solution, so you don't have to solve for y on this one. All right, so I'm going to move the dx over. And then what do you have to get rid of?
Y plus 2.
The y plus 2. So I'm going to divide by y plus 2. Now is this an ln? Yes, because y does not have an exponent. Dang it. All right, so when your variable doesn't have an exponent, it is going to be an ln, even though it has that plus 2. Technically, this is a u sub, but it's an easy u sub that we can kind of do in our head. All right, so when I integrate this, what's the integral of 1 over y plus 2? Ln of y plus 2. And the derivative of y plus 2 is 1, so you don't really have to account for anything, so we're good to go. Like your du would just be dx. All right, what's the integral of e to the x? E to the x, and then plus e. So on this one, if you came across this one and you had to solve for y, you'd have to e and e, which is really weird. So this would be an example where they might give you this on the test, but I seriously doubt they would make you solve for y, because it would give you such a weird equation, right? Because if you were to get rid of the ln, you would have to e. So you'd have e to the x, which is a weird thing to say. Does that make sense? But luckily, we don't have to solve for y. It wouldn't be too hard to solve, it just is weird with the e to the e. But anyways, we don't have to solve for y, so we can take this guy and immediately plug in my initial condition, right here. So in place of y, what are you gonna put?
-1.
-1.
0.
Yep. And then 0 for x. All right, so what is -1 plus 2?
1.
1. And what is ln of 1? 0. What is e to the 0?
1.
So c is going to equal
-1.
-1. And plug that back into this guy right here to get my particular solution. So my particular solution is going to be ln of y plus 2 equals e to the x and then -1. And then if you wanted to sketch the solution, 0, -1 is right here. And it would, oh, that I crossed it. That would be bad. Kind of something like this.
That wasn't that bad.
No, it's just finding, it's the same thing, just finding for C.
I think the biggest thing for me is like